Okay, so we have covered some of the polygons already, including triangles and quadrilaterals. Now we are moving on to other polygons, and they include polygons with many different sides. Okay, so now, what exactly is a polygon? So please follow me for the lesson. Now, a polygon is a flat, F-L-A-T, plane figure. Plane actually just means flat also. Okay, so for example, a piece of paper that is flat, that has no thickness, is considered on a plane. Okay, don't be too bothered about the words, you just take it as flat. Now each polygon is named after the sides it contains. For example, here we have a triangle. Triangle with 3 sides. A 4-sided figure is called a quadrilateral. Quadrilateral. After a 4-sided figure, we've got a 5-sided figure. Do you know what it is called? What is this building in the United States for their defense? 5-sided figure. Pentagon. Heard of this building in the US? They came under attack many years ago. So we see that there's this word GON. Okay, let's move on to the next figure. 6-sided figure is called a hexagon. Again the GON. Then a heptagon. We see that there's a pattern. Once we go past a 4-sided figure, whether it is 5, 6, 7-sided, they all end with a GON. Give me a guess, what is an 8-sided figure called? Yeah, that's a very good try. Octagon. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-sided. Decker. Somehow the 9-sided is not shown. Okay, so just draw your 9-sided figure over here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can do dashes like this to indicate that, oh, we have 9-sideds. Nonagon. Okay, so these are the names for the figures from 3 sides all the way until 10 sides. Do we need to know the spelling? Yes, we do. You may be tested on the names, so you need to know how to spell. Of course, you need to know which name is for which figure. Now, we are ready to come back to this part. A polygon with n sides is called an n-gon. So you can see why it is named like this. N sides, n-gon, G-O-N. They all end with G-O-N. And the words, the portion in front actually indicates the number of sides. Hexa for 6, hepta for 7, octa for 8, deca for 10, nona for 9. Okay. Next, interior angles refers to angles within a polygon, inside a polygon. So right now I'm going to identify the interior angles with red. So these are all the interior angles. No surprise there, they are just angles on the inside. Okay, so on and so forth, you can do for all of them also. So we notice that for a 3-sided figure, otherwise known as a triangle, it has 3 interior angles. For a 4-sided figure, it has 4 interior angles. So on and so forth. How many interior angles will a 70-sided polygon have? 70 lor. Okay, so it corresponds. A regular polygon. If we tell you that a polygon is a regular polygon, it has equal sides and angles. Regular polygon. Okay, so what is the special name for a regular triangle? A triangle that has equal sides and the same angles. What is this triangle called? Starts with E. Yes, equilateral triangle. Okay, so example, equilateral triangle. Okay, what about a four-sided figure that has same angles and same sides? What is it called? Square. It has to be a square. It cannot be a rectangle. Okay, square. Then for 5, 6, 7, 8, we don't have special names for them already. They are just called regular pentagon, regular hexagon, regular heptagon, so on and so forth. Okay? So this is a key point over here that you need to note. Now when each interior angle, every single interior angle is less than 180 degrees. All these angles are less than 180 degrees. It is called a convex. It's just a name, okay? Convex. It protrudes outwards. However, if there is one or more interior angles that is a reflex angle, meaning it is greater than 180 degrees. Example over here. This is one interior angle that is greater than 180 degrees. Then we see a dent. Over here, right? This is a dent. It's like a hole. So we say this is called, what's the opposite of convex? It's concave. Okay? So you need to know these two names. Huh? Most of the time we will be dealing with convex polygons. Sometimes we can have questions on concave polygons. We shall figure out how to deal with them later. Okay, so these are the definitions that we need to know. The next page of our lesson, of our notes. Okay, we will be filling out this table over here. For the first one, name of the polygon, you can just fill them out yourself. Triangle. Number of sides, there are 3. Number of dissected triangles. Okay, how many triangles can you find in this shape? How many triangles do you see? No, it's not a trick question. How many triangles are there? 1. Yeah, okay, it's just 1 triangle. Sum of the interior angles. Do you know what's the sum of interior angles for a triangle? Yes, 180 degrees. Simple? Okay, now, our goal over here, we have a quadrilateral. Our goal over here actually is to find the sum of the interior angles based on your primary school knowledge. What is the sum of the interior angles for a square? It's not 90, definitely not 90. What is the total? 360, right? It's 90 plus 90 plus 90 plus 90. Okay, what about a rectangle? Also four-sided. Is it also 360? Okay. How many other four-sided figures do you know? Trapezium, for example. Do you know the sum of the interior angles? 360? Are you sure about that? How do you prove it to me that it is 360? So this is our goal over here. I'll show you for this four-sided figure. Take any four-sided figure. You start at any corner. Okay? Please indicate with a pen. Start at any one corner you like. I want you to join to another corner. For example, like this. For this four-sided figure, you don't have much choice. You're either going to get my diagram over here, or you're going to start from this point and up. Okay? So either way, you will get 2 triangles. You have dissected, you have separated the four-sided figure into 2 triangles. Now can you tell me what is the sum of the interior angles? Let's take a look at this little this triangle here first. What is the sum of the interior angles? 180. They are made out of 1, 2, and 3 angles over here. Now the other triangle in the 4-sided figure, another 3 angles. And what do these 3 angles add up to? Again, 180. So seeing that there are 2 triangles over there, what is the sum of the interior angles? 360. Does it matter whether it's a square, rectangle, trapezium, parallelogram, kite? Doesn't, because you can always join from one corner to another corner. So what we will write over here will be 2 times of 180 degrees to give us 360 degrees. Okay? I'll show you over here. Okay, so we have done for 4 sides. Let's increase it to 5 sides. How many triangles do you think we can generate from this? Okay. There's 1. There's 2 and 3. Can you see that we can split a 5-sided figure into 3 triangles? Okay, so now you should be able to tell me what is the sum. 3 times of 180 degrees to give us 540 degrees. Please fill in the names over here, all the names from the previous page. Yeah? Now as you go down the line, do you think you can fill in everything already? Okay, let's jump down to an octagon. How many triangles do you think you will get? You can try yourself. Go and cut. 1, 2, 3, 4, 5. I drew 5 lines. That gives me how many triangles? Please go do it yourself. Go and cut and see and discover for yourself, so that it will not be a case of just memorizing formula. Okay, once you have the number of triangles, please fill up the table. Please take note that the second last row is actually a 10-sided figure, not 9-sided. Okay, I give you some time to fill up this table. Number patterns. Okay, so 6 appears here, 8 appears here. You should be able to see the pattern now. What then is the sum of the interior angles? Copy down the highlighted part. We will see it is n minus 2 multiplied by 180 degrees. Okay, so this is a formula that we can use. You don't have to derive it by yourself. And in fact, by the end of this lesson, you would have already remembered this. It is not difficult. Minus away 2 sides times 180 degrees. So the sum of the interior angles of an n-gun is simply n minus 2 multiplied by 180 degrees. Abbreviation is as such, angle sum of polygon. Now, for a regular polygon means that all the angles, all the interior angles have the same size. Okay? Now that I know that the sum of an n-gun is n minus 2 times 180 degrees. If I just want one angle, what shall I do with this? What shall I do with the sum if I only want one angle? Divide by how much? How many sides does this have? N. So what we need to do is n minus 2 multiplied by 180 degrees divided by n. And that's it. Here we have the formula for one interior angle for a regular polygon. Please highlight this word. This is only true for regular polygons, where all the angles are the same. Okay, so concept-wise, any issues? Anything you need to clarify? Okay. Now, we need to find out what these angles are. Find the values of K and the reflex angle PTS. This is a pentagon. 5-sided. Find the values, okay. Okay, I can see that the interior angles, they are all unknowns. However, there's something that I am able to find out. I am able to write down the total interior angle for a pentagon. Okay, so let's add everything up. 5k degrees plus 3k degrees, another 3k degrees, another 5k degrees, plus 4k degrees. This gives us a total of 20k degrees. What is this supposed to be equal to? What is this supposed to be equal to? You are supposed to come up with an equation. What is the total interior angle for a 5-sided figure? Here's where we call out our formula. It is given by total interior angle equals to 5 sides minus 2. There are 3 triangles that we can create, multiplied by 180 degrees. This gives us a total of 540 degrees. So see, even though the interior angles are different, but it is for sure, I can divide this into 3 triangles, and it must add up to 540 degrees. So 20k degrees is equated to 540 degrees, meaning k equals to 27. The value of k is 27. Find the reflex angle PTS. Reflex more than 180 degrees. Reflex means more than 180 degrees. So PTS can refer to either 4K or this bigger angle, otherwise known as the reflex angle. So you need to be able to identify which angle they want based on the name. Since they say reflex angle, so you write down reflex angle PTS has to be 360 degrees minus 4K. 360 degrees minus 4 times of 27 degrees. But what is the reason over here? You used a certain property. Where did the number 360 come from? Angles at a point. Angles at a point. If you leave this out and you just write 360 minus 4 times of 27, yet you arrive at the correct answer, you will still not be given the full marks because you did not write down the reason. Okay, these are very important. Let's move on to the next question. And this is where we will stop for today. The sum of interior angles of a regular. These are the keywords you need to know. N-sided polygon is 720 degrees. So there are n sides, and I know that the sum of interior angles is 720 degrees. How do I find the value of n? There's only one formula that we have learned so far. Angle sum of a polygon. So part A, n minus 2 times 180 degrees. This is the formula for sum of the angles in a polygon. This gives me 720 degrees. Do you see that there is only one equation with only one unknown? That means I can solve for the unknown. Whatever I do on the left hand side, I have to do on the right hand side. I want to be able to isolate n. Okay? After a series of working, it will just be n by itself equals to something. Right now, n, we take away 2 from n. Then we multiply that by 180 degrees. So what is the first thing that we should remove? Is it the -2 or the 180 degrees? We'll be removing 180 degrees first. How do we do that? What should we do to both sides? To remove the 180 degrees. But now this is 180 degrees multiplied by n-2. So to get rid of it, do the opposite. Divide by 180 degrees. So we are left with n-2 equals to 720 divided by 180 is 4. So n-2 is 4. What do you think n has to be? Yeah, it has to be 6. We add 2 to both sides. So here we have part B. What is the name of this polygon? Refer back to your second page. What is the name of a 6-sided polygon? Hexagon. And we're done. Okay? So your homework for today, I wanted to go through part 3 also, but we don't have time.